What is material science? Have you ever wondered why your phone screen doesn't scratch when you drop it? Or why an aeroplane can weigh hundreds of tons, yet fly through the sky? Or how a tiny implant can sit inside your body for decades without causing any harm? The answer to all of these questions is the same: materials science. Welcome to this channel. Today we start with the basics: what material science actually is, and why it matters more than you think. Material science shapes your world. Think about the last time you picked up your phone. That screen is coated with a ceramic glass called Gorilla Glass, tough enough to survive drops that would shatter ordinary glass. When you board a flight, the aircraft body is made from aluminum and titanium alloys, materials that are 60% lighter than steel, yet just as strong. In hospitals, titanium and bioceramics are used as implants, bones, joints, dental fixtures, because the human body simply does not reject them. And when a rocket re-enters the atmosphere at 25,000 kilometers per hour, it is a thin layer of ceramic coating that stands between the spacecraft and temperatures above 1,600 degrees Celsius. In every one of these cases, the material made it possible. The four families of materials, every material on Earth, from the iron in your blood to the glass in your window, belongs to one of four families. First, metals: iron, steel, aluminum, copper. Strong, electrically conductive, and they can be bent and shaped without breaking. That is called ductility. Second, ceramics: alumina, silicon carbide, boron carbide, glass. Extremely hard and heat resistant, but brittle. They do not bend, they break. Third, polymers: nylon, rubber, PVC, epoxy, lightweight and flexible. Most plastics you see every day are polymers. And fourth, composites. A composite is what you get when you combine two or more of these families. Carbon fiber reinforced polymer, used in Formula One cars and aircraft wings, is a perfect example. Lightweight like a polymer, strong like a metal. Four families, infinite possibilities. The core idea: structure determines everything. Now here's the most important idea in all of material science, and it fits in one sentence. Structure determines properties. Properties determine performance. What does that mean? Let us use the simplest example: iron and steel. Both contain iron, but steel has a small amount of carbon added to it. That tiny change in composition, in structure, rearranges the atomic bonds inside the material. And the result? Steel is roughly 3 times stronger than pure iron. Same base element, different structure, completely different performance. This is what materials scientists do. They manipulate structure at the atomic level to get exactly the properties they need. Where is it used? So where exactly is material science applied? The honest answer is everywhere. In aerospace, turbine blades and heat shields are made from superalloys and ceramic coatings that survive temperatures no metal alone could handle. In electronics, the silicon chip inside every computer and phone is a semiconductor, a material engineered to conduct electricity in precisely controlled ways. In biomedical engineering, hydroxyapatite ceramics mimic bone, and titanium implants last decades without corroding inside the human body. In automotive, electric vehicle batteries depend on lithium-ion chemistry, a materials engineering achievement that is reshaping global energy. In construction, high-strength steel and ultra-high-performance concrete allow us to build structures that were impossible 50 years ago. And in energy, photovoltaic cells convert sunlight into electricity because someone understood exactly how electrons move through a semiconductor material. One science, every industry. What you learned today. Let us recap what we covered today. Materials science is the study of structure, properties, and performance of materials. Every material belongs to one of four families: metals, ceramics, polymers, or composites. Change the structure and you change everything. That is the core idea, and this science is behind every phone screen, every aircraft, every implant, every solar panel, every battery you have ever used. In the next episode, we go deeper into metals. We will look at crystal structures, grain boundaries, and understand exactly why steel is stronger than iron at the atomic level. If you found this useful, please like this video and subscribe. It helps more people find this content. Drop a comment below. What topic do you want covered next? I read every single one. See you in the next